You know, behind all the daily headlines about what AI can do, researchers are actually fighting a massive two-front war. They're tackling these really fundamental problems that are going to define the future of intelligence itself. And it really all boils down to two great challenges.
And we're not talking about minor bugs here. These are deep conceptual weaknesses in modern AI. On one hand, you have a machine that really struggles to remember. And on the other, you have a machine that you can't always trust to tell the truth. Solving these two things, that's basically the holy grail for the next generation of AI.
Okay, so let's start with memory. You'd think, right, that a system trained on basically the entire internet would remember everything perfectly. But when it comes to learning new things, it has this critical, almost shocking flaw.
It's called catastrophic forgetting, and honestly, it's something we can all kind of wrap our heads around. Imagine you spend years learning to play the piano. You're great at it. Then you learn one new song on the guitar, and poof, you completely forget how to play the piano. That is exactly what this is like for an AI. Learning today's news could literally make it forget everything it knew yesterday.
So the billion-dollar question is this. How do you build an AI that can keep learning and growing without getting this kind of digital amnesia? This has been a huge roadblock for years. It's actually why most AI models today are trained once and then just frozen in time. They do that specifically to avoid this problem. But a new idea might just change everything. To get around this, researchers at Google are proposing a completely different way to think about learning. Instead of the AI being one giant brain, they imagine it as a collection of nested parts, kind of like those Russian dolls that all learn at different speeds. And the core idea here is just its genius in its simplicity. Think about our own memory, right? We have short-term memory. Those are the faster modules for immediate stuff like what you had for breakfast. And then we have long-term memory, the slower ones for foundational knowledge like how to read a book. This nested learning gives AI that exact same kind of layered ability.
And this is not just a theory on a whiteboard. They built a prototype called Hope, and it already performs as well as or even better than other really advanced models, without needing more power or some crazy new code. And that part about no new complex operations, that's a huge deal. It means labs everywhere could potentially use this without a massive overhaul. But the most stunning result is just the sheer scale at which this thing works.
30 billion tokens. Just let that number sink in. Most research in this area kind of stalls out after a few 100,000 examples. Hope just kept learning, kept improving, from a stream of new data that was orders of magnitude larger. This isn't just a cool lab experiment, it's proof that this could actually work in the real world, with that constant, never-ending flow of new information. Okay, so let's say we solve memory. The AI can learn forever. That's amazing. But it leads us directly to the second great challenge. Because what good is a perfect memory if the information it gives you isn't even true? This is the problem of hallucination.
And that word, hallucination, it's borrowed from psychology for a very good reason. The AI isn't just wrong, it's confidently and fluently wrong. It creates stuff that feels real, sounds totally plausible, even when it's completely unfaithful to the facts it was given. And that's what makes it so incredibly deceptive.
Now, researchers usually break this down into two main types. First, you've got intrinsic hallucination. This is a flat-out contradiction. The AI says the sky is green when the source material said it's blue. Simple enough. But then there's extrinsic hallucination, and this one is way sneakier. The AI adds new information that might even be true, but it's not supported by the source. It's just inventing details out of thin air. Here's what this can look like in the real world. In that translation example, the model doesn't just mistranslate. It invents a totally new person named Jerry. Or look at the sports data. The source says 5 losses. The AI reports 4. Now, these might look like tiny mistakes, but imagine if this were in a high-stakes field like medicine or finance. A small error there could have absolutely disastrous consequences. So how do you stop an AI from just making things up? Well, there's no single silver bullet here. It's more like researchers are waging a war on multiple fronts, attacking this problem from every angle they can think of. So here are a few of the high-level strategies. Reinforcement learning, for example, is kind of like training a dog. You give the AI a little reward every time it produces an answer that's factual and verifiable, and over millions and millions of trials, it learns to favor telling the truth. Other approaches, like multitask learning, try to train the AI on a bunch of related tasks at once, hoping to build a more robust, holistic understanding of the facts.
And really, all these different tactics fall into three big categories. You can tackle the problem before training even begins by cleaning up the data. You can tackle it during training by actually modifying the AI's core architecture. Or you can deal with it after the text is generated by using another system to fact-check and correct the output. And this all brings us to the very heart of the matter, where these two great challenges meet. Because you see, memory and truth, they aren't separate problems at all. They are fundamentally, completely linked.
I mean, think about it. An AI with a perfect, always growing memory that just keeps absorbing new information, but it can't ground itself in reality? That could become an incredibly effective and, frankly, very dangerous source of misinformation.
And on the flip side, an AI that's 100% factual but can never learn anything new would be this static, quickly outdated tool. Its usefulness would just shrink every single day as the world changes around it.
So the real endgame, the ultimate ambition in this whole field, is to create an AI that combines the best of both worlds, an intelligence that can remember everything it ever learns, while at the same time inventing nothing that isn't true. An AI that is both a perfect student and a perfect historian. If we can actually achieve that, what kind of world does that unlock? What becomes possible then?